right, so we're going to go ahead now and finish up by 5. Now, 5 again is more factoring. Okay, it's all zero factor. So whenever we have an equal sign, we have an equation, and we have to make sure it's set to 0. And in some cases, when we set it to 0, we may still have to FOIL after that and kind of collect things together. So these are a little bit different than what we've done, but the same process is going to apply. Let's look now on page 374. And let's look at question 32. And if you don't have your textbook handy, I'll go ahead and write it out for you. So this one's just a little bit different here. Before we set it to 0, we want to go ahead and break up these parentheses because the parentheses are really only helpful when it's equal to 0. When it's equal to 0, we want these parentheses. If it's not equal to 0, we're going to have to break it up, set it to 0, and then refactor it again. So this one's been factored, but it's not set to 0, so we're going to have to FOIL this out. Then we'll set it back to 0 and refactor it correctly. So we're going to go ahead now and FOIL this out. And then we'll set it to 0. So we do need the parentheses, but we only need the parentheses when it's already equal to 0. If it's not, then we go ahead and we FOIL. And so when I FOIL to break it down, that gives me an x times x, so that's an x squared. Then I've got outside and outside, that's a minus 2x. Then I've got the inside and the inside, that's a positive 8x. And then I've got the last times the last, which is a minus 16. And that still equals that minus 21. I'm going to clean this up, and now we've got x squared plus 6x minus 16 equals a minus 21. Now we should know what to do. So if you have parentheses and it's not set to 0, you've got to get rid of the parentheses. Then you get to this step. So we did that by FOILing, and now we should know what to do. We've done a lot of these before, right? What do we need to do? We need to set this equal now to what? 0. So we're going to go ahead now and add that 21 on, and we're going to have to then refactor it. So we're going to go ahead and add that 21 on, and that gives you then an x squared plus 6x plus 5, and that equals now 0. How does this factor? Well, we put the 1 in front, and this one's going to be easy. 1 times 5, because we have 3 terms. We take the first times the last, and we split the middle. So it's going to give me a 5 over in the box. Okay, while you're copying it down, can someone tell me what the signs are going to be? First off, are the signs going to be the same, or are they different? Look at the 5. What's the sign of the 5? Positive. Okay, what do we know if they're positive? They're the same, okay, because they have to either be both positive or both negative. Are they both positive or are they both negative? Which one and why? Positive. Why? Because the middle is positive. Now we look here. We look at the 5, and we compare it to the number in the middle, which is 6. What do you know about 5 and 6? They're really close together. So can someone tell me what the two numbers here would be? 1 and what? 1 and 5, right? I always write the larger one first. So the 5 will go first. I'll go down below. Now we've got it. Hard part's done. Now we split this up, factor it, and it's over. That gives you then x squared. We split the 6x up into 5x and an x and a 5, just like we've done before, numerous times. Factor that x out. Factor a 1 out over here. These are the same. So now we've got x plus 5, right? X plus 1. It is now set to 0. It has been refactored. And now how do we finish it? What's my next step here? Okay, we got to this point. What do I do next? How do I finish it and get my answers? We just did a couple of these before break. It's been set to 0, right? So what do? We set each piece equal to what? 0. So that gives you x plus 5 equals 0. So what's that one going to then give you for your answer? X equals what? We have to move it over. So what would it give you? Negative 5, right? Remember, you got to move it over. So that makes one solution then. X equals negative 5. What about the other one? Yep, negative 1. And where did that come from? That came from x plus 1 equals 0. So move that 1 over. So x equals now that negative 1. So that's what we did. We FOILed it, set it to 0, refactored it. Question 38. Similar, but a little bit different. So we've got 3x plus 1, x minus 3 equals now 2 plus 3 times x plus 5. So what we need to do is we need to get this to the point where we can set it to 0. Now, we've got all these extra parentheses. We're going to have to refactor them. So we need to first get rid of all these parentheses so then it can be set to 0 and refactored again. So that means we're going to have to FOIL. We're going to have to use the distributive property. So let's go ahead and work with this. I'm going to work on the left side first, and I'm going to go ahead and FOIL it. You shouldn't have any trouble foiling here. First times first, 3x squared. Outside and outside, minus 9x. Inside, positive x. Last and last is a minus 3. We'll go ahead and work on the other side as well. On the right-hand side, that 3 has to be pushed through. So that's 3x plus 15. Okay, so all the parentheses are gone. Now let's clean it up a bit. Then we'll set it to 0, and we will get our final finished answer. So clean these up. So that gives you a 3x squared minus 8x minus 3. Other side, we've got a 3x. 2 and 15 makes it a 17. So nothing really new. All we're doing is getting rid of our parentheses so we can eventually set it to 0 and refactor it. Now what do? Well, we can easily move things around, so let's do that. Move the 3x over. Move the 17 over. We now have 3x squared minus 11x. It looks like a minus 20 equals 0 there. Okay, so now we're here. And how many terms do we have? 3. Okay, so what's the procedure for 3 terms? We take the first times the what? Last. Okay, first times the last. So that's 3 times a negative 20. Negative 60. What do we know about the signs? They're both positive, they're both negative, are they different? What are they going to be? Okay, they're going to be different. which one's going to be larger, the positive number or the negative number? Okay, negative number will be larger, so it goes first, right? Because that's negative there. Positive goes over here. Now we've got to try and find it. Okay, so what do we know? 60 ends in a what? 0. So what does that tell me? 5s and 10s. It's got to be one of those. 60 divided by 5. 5 and 12. Well, 5 and 12, when we subtract them, do we get 11? 5 minus 12, is that 11? No. 60 divided by 10. 10 and 6, when I subtract them, that's 4. Doesn't work. 60 divided by 15, that's my next one. 15 and 4, that's going to work because 15 minus 4 is a what? 15 minus 4 is 11, and 11's in the middle. Is everyone okay with how I got the pattern? So if it ends in a 5, multiples of 5. It ends in a 0, multiples of 5 and 10. Even numbers, try multiples of 2. Odd numbers, those are trickier. You might have things like 7 and 11, different odd numbers. But we found it, and we found it to be 15 and 4. Always write the larger number first. That way you keep track of the signs. Now we split it up, and so that's 3x squared minus 15x plus 4x minus 20. Okay, factor here. What can we factor out of what I've got underlined? Can someone tell me? The blue part that I've got underlined. Yep. And what else? Yep, 3x can come out. Okay. Just making sure we're on the right track here. And what does that leave you then with? If I factor that out, that leaves you with a x minus 5. Very good work there. Next, what can come out? Yep, these have a 4 in common, right? They don't have an x because 20 didn't have an x, does it? Have to have that to come out, doesn't? But a 4 can come out. And that leaves you with an x minus 5, doesn't it? Now, how do we know we did it correctly? If we did it correctly, these should be the same. Are they the same? Yes, so we know we did it correctly. If they are not, you made a mistake. So now we've got x minus 5 and 3x plus 4. And that still equals your 0. Now we should know what to do. Get our two solutions. So what are they going to be? One of them is x minus 5 equals 0. So that's going to give you x equals now what? 5 when you move it over. You've got to make sure you move it over. So there's one of them. It's squared. The original was squared, so I should have 2. What's my other one? Okay, it's a little bit more complicated. 3x plus 4 equals 0. So 3x equals a negative 4. We divide by our 3. So x now equals a negative 4 thirds. There's your two solutions. And we have solved it. Okay. All right, let's do another one here. Let's look at how about question 51? Okay, now 51, a couple of different ways of doing 51. So question 51 is already set to 0, so we've got 2 times x minus 1 quantity squared minus 7 times x minus 1 minus 15, and that equals 0 already. And just so you have one to reference in your homework, this one is going to look like question 16. There's only one of them like this, so this one is like 5.5 homework, number 16. Very similar, different numbers is all. Now, when I look at this question, it's set to 0. And I know we did a few of these back in 5.2. It's been a while, but we're going to factor this as a trinomial because I'm looking at it as 3 terms. When I look at it holistically, I see there's 3 terms. Now, nothing comes out because I've got a 2, a 7, and a 15. So they do not have anything in common. So it's the first thing I do, it's set to 0. Holistically, 3 terms. Now, how do we factor it? Well, we take the first times the last again. So this is 3 terms, so we're going to do it like we normally would. First times the last. Okay, first times the last, that's a negative 30. And what do we know about the signs of the 2 numbers that we're going to need? Are they positive both, negative both, or are they different signs? Different signs. Which one's going to be the larger one? We look again in the middle. Negative. So we need a negative and we need a positive. And this one should be pretty easy again to find the 2 numbers. It ends in a 0. So we're going to start off with 5 and 10. So 30 divided by 5, 6. 5 minus 6 is 1. We want 7. Let's move on up. Let's try a 10. 10 and 3. 10 minus 3 is a what? 7. 7 is what we want, isn't it? So what are my 2 numbers going to be? Negative 10, positive 7. Now I know that we factored these out in 5.2. We did several of these. These were the more difficult ones. We did them though. We broke it up into 4 pieces, factored by grouping. So that's what we're going to do here. Okay? We got our numbers. We're going to take this middle and we're going to split it up. And so now we leave the ends the same. So 2 times the quantity, x minus 1, quantity squared. Then we've got a minus 10 times x minus 1. And we've got a 7 times x minus 1. And then we've got a minus 15. Stays the same.
Is that 7 supposed to be a 3?
Yes, it should be. Should be. Yep. My mistake there. That should be a. I wrote down the wrong number. Should be a 3 there. Sorry about that. Yep, because 10 minus 3 is 7, and that's in the middle. So now we've got to this point. And now we're going to group them together. And so we're going to group the first 2 together. Now we look for numbers in common, and there might even be an entire set of parentheses in common. There is an entire set of parentheses and a number, because 2 and 10, they have a 2 in common. These also both have the same parentheses, and that's an x minus 1. And then just to make it easier, I always use square brackets so I can keep track of things. 2's cancel. The x minus 1, they're squared, so we took out one of them. So that leaves you with an x minus 1. And then we've got a minus 10. Well, minus 10 divided by 2, that's a minus 5. And the x minus 1 came out. Next 2 pieces, we look at the numbers. And 3 and a 15, what can come out? What number's going to come out of here? Can someone tell me? Looks like they have a 3 in common. Yep, someone said a 3, so 3 is going to come out. And what's that going to leave you with? X minus 1, right? And 15 divided by 3. That leaves you again with that negative comes down, so that's a negative 5 there. Now we just kind of clean it up a little bit, and we're almost done. Okay, so I'm going to go ahead and clean these up, because these can be cleaned up. These are the same. They can be cleaned up. Because that can be an x minus 6. I'm just cleaning it up so it's a little bit neater to work with. And x minus 6 over here, right? They're the same. Just condensed it down a little bit. And these are the same. So that's going to come out in front as an x minus 6. Gone, gone. And what's left over? 2 times x minus 1 plus 3. And I'll slow down a bit so you can get caught up. These are, I only gave you one of these. You're not going to see anything like this on your final, because I took those questions out. In the past, I've given you some, but when I wrote up your practice one, I took them out. We got to this point. Now we need to clean it up, because it's still set to 0. So I'm going to go ahead and clean it up by distributing that 2 through. And we can mentally combine them here. And so now we've got x minus 6. We've got a 2x from here. And we've got a minus 2 plus 3. That makes it a 1. And don't forget, this is all equal to 0. And now we're finished. Because it's the same here. So we're finished. So what are my two solutions going to be? X minus 6 equals 0. So x equals 6. There's 1. What about the other one? It is 2x plus 1 equals 0. So 2x equals negative 1. And so x now equals a negative 1/2. We still need to do 2 more topics in this section. We need to look at some literal equations and also some applications. So we'll go ahead and do the literal equations next. And I only gave you one of these in your homework. So I only gave you question 13. So we'll do one that's going to be like question 13. And we've done this type of question before. We did it way back in chapter 1, but we're reviewing again with factoring. This is on page 376, and we're going to look at question 77. And so I'll write it up, and then I'll tell you which one it aligns with in your homework. The one in your homework is almost the same, it's just different numbers. So this is going to be like homework. Which one is it? It's going to be like question 13. In 5-5. It's just different numbers. Different variables. That's it. We have done this type of problem before. They bring it up again because we're going to use factoring again. When we did it in chapter 1, we solved with factoring, and we kind of barely introduced factoring, but now we have a lot more clearer understanding of factoring. So we're going to do it again. This is a literal equation. Now, literal equations just mean they're equations that have more than one variable. And this one does. And when we solve this literal equation, they have to tell us what variable to solve for. And so we want to solve now for the y. So we need to begin by clearing out the fractions. So I'm just going to put this over 1, and I'm going to cross multiply. The one in your homework is almost exactly the same, except instead of solving for y, you're solving for t. No real difference. So we're going to go ahead and cross multiply. And so that gives you now wy equals 3y minus x. Now we still want to solve this for y. So that means we need to get all the y's together on the left-hand side. So Here's a 3y, and we wanted to join this w1. We want them together on the left-hand side so that we can factor. That's the goal, is to factor. So let's get all the y's together, because that's what we want on the left-hand side. That's the variable that we're solving for. So move the 3y over, and that gives you wy minus 3y equals now a negative x. And we should know what to do. I've got it underlined. What can I factor out of the underlined blue part here? What can come out of here? It looks like a y can come out. Okay, and that leaves you then with the y. And then we've got a w minus 3 left over. And the last step is we want to get the y by itself. So how do we do that? We divide by w minus 3. And that leaves you then with y equals now, when we reduce it down and rewrite it, a negative x over w minus 3. And that's it. That is your final, finished answer. That's what we want. Now the one in your homework, only difference is the variables. That's it. It is exactly the same. Only difference is the variables, and I think the numbers may have changed too. Yep. Instead of a 3, it's got an 8. So very, very similar. Instead of a y, it's got a t. And a c instead of a w. Same type of problem. The last part of this section is beginning to look at what you're going to find in college algebra. And we're going to look at some applications. And so on these, we're going to have to solve them out by factoring. Once we get a solution, then we're going to have to see if it makes sense. In many cases, we get 2 solutions, but only one of them makes sense because we can't have things like a negative length or a width. So you're probably going to get on these 2 different answers, but one of them may make sense and one of them may not. And we'll do 2 of these, and we're going to look now at question 58. And I only gave you a couple of these in your homework. I didn't give any of these on your practice final or your take-home final or your final exam, but you will see them in college algebra. This is one of the very first things that you're going to be working with in college algebra. Second week, you're going to be doing these type of questions. So we're going to look now at 58. Whenever we read these type of questions, pick up on key terms like square. Square tells me that all the sides are the same. So a square mirror has sides measuring 2 feet less than the sides of a square painting. So that's what we got here and here. If the difference between their areas is 32 square feet, find the lengths of the sides of the mirror and the painting. Now, we want to find the areas. So we're going to look at each figure, and we're going to find its area. So we want the areas. And we're going to start with our picture. And this picture is x by x. So what would this area be? Okay, length times width. It's very simple. Don't make it more difficult than what it needs to be. Length times width. That's x times x, which is a x squared, right? Length times width there. What about the other one? The mirror's a little bit smaller. And that's x minus 2 and x minus 2. So that area would be, those two going together, x minus 2 quantity squared. Now, what do we know? We know that the difference is, 32? Yep, it says the difference of them is 32. So our difference is going to be 32. So what does that look like as an equation? Difference between these is going to be 32. So that's going to be x squared minus x minus 2 quantity squared equals now a 32. And you can label these as 1 and 2 if it helps, or painting in picture, or painting in mirror. Doesn't matter. But we're going to subtract them, and we get 32. These are all about areas, and areas length times width. For rectangles, and for squares, well, it's the same, length times width, but they are the same. So that's why this one's x squared, and this one's x minus 2 squared. Now we've got this question, and we need to solve it. What do we need to do? Eventually, we need to get it to 0. So we need to get rid of these extra parentheses. So we're going to go ahead and begin by foiling. So let's go ahead and FOIL out that x minus 2 quantity squared here. Write it out and FOIL it. When I FOIL it, x times x, that's x squared, minus 2x, minus 2x, negative and negative makes it a positive 4. So that's x squared minus 4x plus 4. We're on the right track there. So we went ahead and we squared that out. We got to this point. Now, what do we need to do? We still need to distribute that negative through. Do not forget that negative has to be forced through, all of it, because it was out in front. So the negative was still out in front, and that negative has to then be forced through. And forcing that negative through, we then get x squared minus x. Negative and negative makes it a positive 4x. Negative and positive makes it a minus 4, and that equals 32. These are just keeping track of things. It's not difficult. It's just rewriting, and making sure we don't make a mistake. Now we need to clean it up. So every time we do a step, we see if we need to clean it up some more, which we need to clean these up. This one's really nice because things are going to cancel. So these x squares will cancel. And now we're left with 4x plus 4 equals 32. And now we can finish it. Now, this is linear. We don't have any squares at all. We cannot factor this. All right, so nothing can be factored. Why do we not need to worry about factoring? Because this isn't a 4x, and we can solve it, right? It's linear. So if it was x squared, we'd have to factor it, set it at 0. But this one's linear. So we can solve this linear equation by simply bringing that 4 over. Did I make a mistake? Yep, you're right, minus 4. Sorry about that. You got to make sure you don't accidentally copy the wrong sign down here. Thank you for telling me that. I just wasn't careful. Okay, now we've got that 4, so we're going to move that 4 over. And that gives you then the 36. We'll divide by our 4. And that should then come out to be 9, I believe. Yep, 36 divided by 4 should be 9. And it is. Now, that's what we wanted for part of the answer. It says find the lengths of the sides of the mirror and the painting. So when we look at the painting, this one is the painting. What's the sides of the painting? X. So what's the X? 9. So what's it going to be? 9, and my units of measure are in feet. So my first solution is 9 feet. And what about my other one? Okay, this is the mirror over here. What about the mirror? The mirror was x minus 2. and x minus 2. So that's going to be 9 minus 2, which is then a 7. So the mirror has a length of 7 feet. And the painting is 9 feet. And you could check it if you wanted by calculating the areas and subtracting them and getting 32. But we did it correctly, and those should be your 2 answers for that. 1 for each one. Let's do one more. Then we'll take another short break. We'll come back and we'll spend the balance of our class time working on some questions from our practice final. Question 60. This one I think is a little bit easier. A sign has a shape of a triangle. The length of the base of the sign is 3 meters less than the height. So there, he drew it out for you. What are the dimensions of the base and the height if the area is 44 square meters? So I think this one will actually be a little bit easier. So this one's actually going to be a little bit easier. So let's draw out our triangle here. And this is h minus 3, and this is h. Now, area of a triangle. Is a little bit different. The area of a triangle, if you forget, you can go to the back cover of your textbook. The area of that triangle, if you look here, right, you'll find it over here. Okay, area of that triangle, get the right part here. Let's see, rectangle, triangles right here. Area is 1/2 base times height. So what would the area of this triangle be? If we just use with variables, what do we have for the variables? Okay, area is length times width, so that's going to be 1/2, right? Base times the height. We'll just put the h out in front, so that's going to be an h times h minus 3. So there's that part. That's the area of the triangle. And the area of a triangle is also, from this question, 44. So it is also 44. So that gives us then our equation. So we know we've got 1/2 times h minus 3 equals now my 44, right? Because there's the area of the triangle. That's what we found it to be. We'll write up the area form in the case we need it. Area equals 1/2 base times the height, right? We looked it up and found it in our textbook. There's your formula. We used our figure to get it. It said it's also going to be equal to 44. So we said that's equal to 44. Now we can finish it. We're going to distribute through. Then we're going to clear our fractions, set it to 0, and factor. So distribute that 1/2 h through. And that's going to be 1/2 h squared minus 3/2 h, and that equals 44. Nothing new there. We've done that many times. We need to now clear our fraction. So to clear the fraction, we're going to multiply everything by a 2. That'll clear out all of our fractions. So let's go ahead and multiply everything by a 2. And that's going to give you h squared minus 3h equals 88. Now we should know what to do. We've got to set this equal to 0, and we're going to try and factor it. So move that 88 over. So that's h squared minus 3h minus 88 equals 0. First times the last is going to be an 88. Okay, now, here's something else that might make it easier when you go to factor something like this. When I look at this, look at the 88. 88, if you had 33, if you had 55, if you had 77, these digits are the same. If they're the same, it has a factor of 11 already in it. Now, we know that it's a negative 88, so we know one's positive, one's negative. Sign in the middle is negative. And let's try 11. What happens if we use 11? Well, that's 11 and 88, right? Or not 88, 11 and 8, my mistake there. So 11 and 8, and 11 minus 8, what does that give you? 3. So we already found it. So look for things like that. 88, 66, 77, if they repeat those digits, it's got 11 in it. And chances are, 11 is going to be one of your factors. So now we found them. Now we can rewrite as h squared minus 11h plus 8h minus 88. Factor your h out of the first two, and that's h minus 11 left over. Factor an 8 out of the last two, and that's h minus 11 left over. And we know those are the same. So h minus 11, h plus 8. And don't forget, that all equals 0. Now we're done. Now we just get our answers. One of these is not going to work. I will tell you that. One of these is not going to make sense. What are my two answers going to be? H minus 11 equals 0, so h equals 11. H plus 8 equals 0, so h equals a negative 8. Now, when I think about what h is a height. And I've got two different answers. Which one of these do you think is not going to work? 11 or negative 8? Can I have a negative height? No. Okay, so you got two answers, but the negative 8 is not going to work. Why? Because it's negative. When you solve these type of questions, the mathematics doesn't know what the problem is. It doesn't understand that this is a problem that involves lengths and widths. It just solves it. You just solve the question. When you get to the end, though, you have to go back and think about what it is. How does this work? What kind of application does this come from? And we look at it, we know it's a triangle. Well, the triangle cannot have a negative height. It doesn't make sense. Now, what we do need to get is we do need to get the dimensions of this triangle. And remember, that triangle was h tall and h minus 3 below. So the h goes with the 11. So this is 11 here. Our units of measure, in this case, are in meters. So this triangle has a height of 11 meters. And the other one is 11 minus 3, which is then 8. So it has a base of 8 units wide. So that should get you through now 5.5. We'll take a short break. We'll come back. And then we will look at our practice final. I've got it already worked out for you. I put it in Canvas last week, so you can go ahead and look at it and see how they worked out if you want to. But we're going to spend probably get done a little bit early, but probably the next 30 minutes when we get back working on that practice final. So let's take